All right, so here's a constant uniform acceleration problem. It says you merge onto a freeway with a speed of 30 miles an hour. So you're going onto a freeway, and you want to speed up quickly here, and you're going 30 miles per hour, and then you're zipping off this way, and you accelerate uniformly for 600 feet and only 15 seconds. How fast is the car moving after this time? So let's look at the equation of the day here. This is going to be 1 half VI plus VF delta t. And we'll list the variables. Delta x, VI, VF, and delta t, the change in time. Now I mixed these up. Some are in the right units, some aren't. We have 600 feet, which is definitely not in meters. So I'll have to convert that here in a second. The initial speed. Is 30 miles an hour. 30 mph. The final speed we don't know, and that's what we're trying to find. How fast is the car moving? And the time is only 15 seconds. Okay. So we need to figure out how fast the car is going in this 15-second period, how much it speeds up. That's what this is going to tell us. Now it's already moving 30, so we're going to find this final velocity. So let's convert some things around here in green. So we got 600 feet over 1 times feet meters. 1 meter is 3.28 feet. And what does that equal there? 182.9 meters. Okay. The initial velocity is 30 miles per hour, so that would be 30 miles over 1 hour. And we're going to have miles on bottom, right, kind of small here, meters on top. 1 mile is 1610, and that's going to cancel. And then we have hours and seconds. 1 hour, 3,600 seconds. And we do that math, and what do you get? 13.4 meters per second. This we don't know, and our time period is good to go. So we'll plug all this stuff in here and see what happens. This is 182.9 meters equals 1/2 times the initial speed of 30, or no, not 30. That's what we started with. It is 13.4 meters per second plus VF delta t, which is 15. There we go. All right, so we tried this problem and had a little issue with it, because here's the deal. If you take 600 feet and 15 seconds, that actually is a deceleration. So when we figured this problem out on the board, the final velocity is actually less than what you started with. So it's kind of like merging onto the interstate and hitting the brakes a little bit. And that's just silly. So what I'm going to do here is change this problem. Instead of 15 seconds, since it's already in seconds, we won't have to change it. And let's just make it 6 seconds. Okay, so we'll come down here and erase this and make this 6 seconds. Not a big deal. And this will become 6 seconds. All right. Now let me show you. Everything else would be exactly the same. Okay, I just didn't want to confuse anybody and have the final velocity be less than the initial, because that would be confusing. I wouldn't want that to happen. So, yeah. To finish this problem off now, we'll have 182.9 meters equal. And the trick to doing this is we can take this 1/2 and this 6 seconds here and just multiply them. So half of 6 is 3. Check that out. VF. And then we would distribute this 3 through here. All right, so it's 182.9 meters equals, that's what I get, by the way, for making a problem up without double checking it. 3 times 13.4 times 3 would be 13.4 times 3 would be 40.2. 40.2 plus, and then 3 times VF would be 3 VF. Okay, now we're going to subtract 40.2. 40.2. Just working some algebra here. 182.9 minus 40.2 is 142.7 equals 3 VF, and we would divide by 3. So we take that, divide it by 3, and we would get a speed, a VF in meters per second of 47.5-ish. It's actually 0.6 if we're rounding, 0.6. And that's meters per second. So let's convert that to miles per hour, and I think it's going to be quite dramatic. This would be 47.6 meters per second. Meters, miles, I'm converting it to miles per hour now. 1 mile is 1,610 meters. Of course, there we got that. And the seconds would go up here in hours. 1 hour is 3,600 seconds. That would cancel. So we would take that number divided by 1610 times 3,600, and it would be about 106 miles per hour. Okay? Miles, 106.3 miles per hour. And keep in mind, because you accelerated 600 feet in 6 seconds instead of 15 seconds. So it would be quite an increase in speed. I do invite you to go back and try this problem with 15 seconds in there. I think a lot can be learned in science by making mistakes, and that's the truth. It happens every day. So if you do that, the speed at 600 feet over 15 seconds is less than 30 miles per hour, and I goofed that up when I made this problem up. But there you go. It would actually be a deceleration if you did it in 15 seconds, and the VF would be smaller than VI. All right. Have a good one.